In Chapter 9, we're going to look at the parabola and its more formal definition. So we know that a parabola, and we would say that a parabola is a U-shape. It follows a particular pattern in that function in format ax squared plus bx plus c graphs to give us this parabola. We also saw a much more convenient format for the way the function could be written in when we completed the square, and the reason that we did that back in the previous chapter was to show that it was a nicer format for finding the vertex. Well, now we're going to actually look at the parabola more formally, I would say. So you know that I've spoken a lot about senior maths being looking more maturely at the maths. This being able to express shapes that we're familiar with in maths in a more formal way is another aspect of the maturity of maths. So you know that we've got many shapes in maths, for example, a line, a circle, a parabola, and I guess we have just previously, you've just described the set of points that when you graph them, you've described them using those terms. A line, it formed a line, it formed a curve, it formed a cubic, etc. It formed a U-shape, which we call a parabola. But you might be aware that there is a more formal description for these shapes. Now, that more formal description is called the locus. Now, it's just a term, and it's just a more formal description for a shape you already know. Some of you might know the locus, or the more formal description, for a circle. Now, it's a little bit hard to describe a circle because we just say circle, and we know that set of points. It's a circle. In maths, there is a definition for that set of points, and it says that a circle is a set of points all equidistant from a fixed point. Now, we know that fixed point is the centre, and if you take a point, and we call that point the centre, we decide on a fixed distance, 1 centimetre. We plot every point that is 1 centimetre away from our fixed point, then you will form a circle eventually if you plot enough points. So back to the concept of locus, there's the locus for a circle. We're eventually going to, in this chapter, work on the locus of the parabola. And so we're going to learn, but not in this very first exercise, but in exercise 9b, we're going to learn the formal worded description for a parabola. And along with that comes some other features of the parabola that we've never spoken about. So just to introduce you to this concept of locus, we're going to look at a few different shapes in 9a. They're not unfamiliar. They're shapes that you will eventually recognise this formal description for. So we will look at a straight line. We will look at a circle. We will look at a parabola will even come up in this exercise, but we won't actually look in detail at the features of the parabola yet. Another term that I will clarify just before we get too far into this that you'll hear me use a lot, and I'm sure you probably wouldn't be familiar with the term, is this set of points, a set of points. Now you'll hear me refer to the set of points. Now this set of points might make a straight line. This set of points might make a circle. This set of points might make a parabola. So a set of points is just, I guess what we've previously called a shape. Now, we know that when we draw our graph, we might only plot a few points, but it represents an infinite set of points. So how do we draw the graph? We're usually given an equation. We can illustrate it on an XY number plane usually, and we might also use a table of values to help us to get there. So we've got those three ways of representing this set of points. Now I'm going to introduce a fourth method for describing this set of points. Formally, it's called the locus. The locus. So the locus description tells me the geometric description of how the points are determined. So remember I said for a circle, we take a fixed point, and to you and I, we call that the centre. We measure, determine a fixed distance, like I said, maybe a centimetre, and we plot as many points as we can 1 centimetre away from that, which we know also has a name. We call it the radius. When I've plotted enough of these, I end up with this shape, so which we call a circle. We rarely describe that shape as the set of points which are 1 centimetre from a fixed point called its centre. We rarely use that, we just simply call it a circle. So here I've got describing a circle as a set of points equidistant, which is the radius, from a given point, which we call the circle, is just an example of a locus. It's a more mathematically mature way. Well, it is the only way to describe the set of points in a geometric way. It's the only method. So we could do that. We're not going to do it with all shapes, that we know, but you would be able to find a geometric description for all the shapes that you've come across so far. Some of them get extremely complicated, and we're not going to look at those. But as you're going to come across some descriptions, and from those descriptions, you will then recognise the shape that's formed from this particular written description. So that's what this exercise 9A is all about. And like I said, eventually the focus comes back to just the geometric description of the parabola. And like I said, that then, because of its description, there are some additional features that we have never spoken about. You know the vertex, but there are other features of the parabola that you need to be aware of. I'm going to stop the video at this point and put the examples in the next video.